Everyone, welcome back to the channel. I hope you all are doing great. So from today's video we are starting with the new unit, that is our heterocyclic compounds. Okay, so before starting the class, if you are coming to the channel for the first time, make sure you subscribe to the channel and you press the like button also for the video if you understand the concepts, and do share it with your friends as well. So let us begin with our chapter, which is our heterocyclic compounds. Okay, so the word heterocyclic compounds, compounds will be there. Heterocyclic, it is made up of the two of the words. One word is your hetero and other is the cyclic systems. So cyclic word means that my rings will be present in our compounds. Okay, and what is meant by this hetero word? Now, generally in the organic chemistry, we deal with the molecules in which your atoms contained are your carbon, and mostly is your carbon and hydrogen are only there. But in the hetero atom, if that carbon atom from a particular compound is replaced by some other atom, that is, suppose you have oxygen, nitrogen and the sulfur type of the atoms are replacing your carbon atoms from your compounds, such compounds are called as your heterocyclic compounds. What it means? So suppose this heterocyclic compounds we can have. Now cyclic systems we are to consider. Okay, so because cyclic word means rings we are to consider. So your rings could be either, it could be your saturated, in which the carbon carbon bonds are your single only, and rings could be your containing the double bonds, that is your unsaturated, or you unsaturated rings where generally they are your aromatic compounds, right? So these two can be there. So that means our heterocyclic compounds, based upon that we can classify them as saturated heterocyclic compounds, or we can have as your aromatic heterocyclic compounds. So these two classifications of this can be made. Now the examples of your saturated heterocyclic compounds can be, now here we have, suppose this three membered cyclic ring is there. So here all the atoms are your carbon carbon and the carbon is there, right? Now if suppose one of the carbon atom I am replacing it with some other atom, suppose here I add on nitrogen, and one hydrogen will be there because nitrogen has three trivalency it is there, so three bonds it has to make. So one hydrogen atom will be there. Now this ring that has been formed, it is called as your Aziridine ring. It is called as your Aziridine ring. Okay, so this is your first heterocyclic compound. Next is, if I replace this carbon with the oxygen atom, in that case we are gonna get as the ring, which is like, which will be looking like this, and this ring is called as your epoxide ring, right? Now similarly, this, there like the three membered ring, there we have the four membered rings also, and in that if one of the carbon atom is replaced with the oxygen, that ring will be called as your Oxetane ring. It is called as your Oxetane ring, right? Now similarly we have the five membered rings also. So in the five membered ring, if one of the carbon atom is replaced with the oxygen, the ring is gonna look like this, and this ring is called as your tetrahydrofuran. Tetrahydrofuran. So now what is this furan? You will be getting to know in your aromatic compounds, right? So aziridine ring, epoxide, oxetane, tetrahydrofuran. Similarly, if for the nitrogen you look species, so if five membered ring containing the nitrogen, it is called as your piperidine. It is called as your pyrrolidine ring. Pyrrolidine ring. Dine ring. And if six membered it is there, that is known as your piperidine. It is called as your piperidine. So these are your saturated heterocyclic compounds in which the carbon carbon bonds, it was your single only. So replacing one of the carbon with some hetero atom, it is giving us the saturated rings only. So three membered. If nitrogen is present, it is called as your aziridine. Oxygen is present, it is called as your epoxide. Four membered, if oxygen is there, it is called as your oxetane. Five membered, if oxygen is there, it is called as your tetrahydrofuran. And if five membered nitrogen is there, pyrrolidine. And if six membered, it is called as your piperidine. So generally these saturated uh, heterocyclic compounds you have been seeing in the reactions, these are used as your solvents. Most commonly tetrahydrofuran we have seen, it is written like this, na, THF on the reaction conditions, right? So this THF is basically your tetrahydrofuran, which is mostly used as your solvents. And this nitrogen containing 5 and the 6 membered ring, the saturated species, you can make use of them as your bases can be there, right? Because nitrogen is having the lone pair of the electrons and that can abstract the acidic protons. So generally your saturated compounds are used as your solvents or as a basis you can make use. Now let us have a look over to the aromatic heterocyclic compounds. Okay, so now we are gonna discuss is our aromatic heterocyclic compound. So the most common heterocyclic compound we know in our organic chemistry is our benzene ring, right? So we have this benzene ring. Now from this, suppose if I replace this two of the carbon atoms with the hydrogens with the oxygen, so we are getting is a five membered ring getting being formed, right? Now here the rest of the bonds are remaining the intact. Okay, so this is known as your furan. This is known as your furan. So in the previous case, it was your tetrahydrofuran, which was the five membered ring containing the oxygen. Here also we are having is the five membered ring, but in the previous case, if the hydrogenation of it, suppose I am doing, so this alkenes have been converted to the like this species. So here hydrogen addition, if it is done, it becomes your THF. Okay, so now moving on to our next heterocyclic compound. If we have the replacement of these two carbon atoms with a sulfur atom, that will be known as your thiophene. Like this species will be there. This is known as your thiophene. Okay. Now if I replace this with the nitrogen atom, so like this nitrogen atom, if it is the rest bond are remaining the same, here we have the hydrogen. This particular heterocyclic compound is called as your pyrrole. Okay, so five membered ring containing the this nitrogen as a in the aromatic species is your pyrrole. Now if hydrogenation of it we are doing, it is called as your pyrrolidine, right? Sorry, pyrrolidine, yes, pyrrolidine it was called. Similarly, now here if we have one of the carbon atom is getting being replaced with the nitrogen, in that case we are gonna get as the seven membered ring, six membered ring with the nitrogen, which is called as your pyridine. This is called as your pyridine. Okay, so this is about your heterocyclic compounds, which we can classify them as your saturated one, in which only the carbon carbon bonds are your single. So similarly in the rings also no unsaturation is present. So these are the names of the heterocyclic compounds. And for the aromatic, from the benzene you can derive this. Now I'm saying that all of these is aromatic. So are all of these aromatic? Let us have a look over to that. So here in the benzene we are having, so firstly you can see the condition for the aromaticity to be present in any compound is your, the molecule should be cyclic. The conditions that we have is cyclic, it should be there. Next is they should be planar, that means all the atoms should be either your sp2 or the sp hybridization we are having, right? Next is there should be presence of the conjugated double bonds, that means at the alternate positions your double bonds should be present. Next is they should follow the Huckel rule. Huckel rule, that is they should have the Furan plus 2 pi electron system, it should be there, right? So these are the conditions for the aromaticity that should be satisfied. Now in the benzene, if we see, here we had was benzene, right? So like this the bonds are present. This could be also present in this form. So this side also we can have the bonds. So that means in the overall resonating structure we are having is the ring that is present in the complete system, like this we generally denote it. So here in this you can see the p orbitals that are present is gonna contain your electrons, right? So see, electrons are present in this p orbitals. So here you can see that the electron density is your shifted like this among these p orbitals, which means they are in the conjugation with the one another. So same condition we require in the aromatic systems that I have written, be it your be it your furan, pyrrole, pyridine, thiophene. So in all the molecules this particular conditions should be satisfied. So here also number of the pi electrons, if you see, 1 2 3 4 and 5 6. So if n value, if we keep equal to the 1, so in that case we are gonna have a 6 pi electron. So in benzene this condition is getting being satisfied. Now in the molecules that I have drawn previous in the on the previous slide, that we are gonna see that if they satisfy these conditions or not. So first molecule you consider is your pyrrole. Okay, so here again one hydrogen atom is there. So now the nitrogen is containing the lone pair of the electrons over here, right? So now here also you are gonna see is the overlap among the p orbitals, like this the p orbitals are present. Now the electron density is present in all these p orbitals. So these ring are in the conjugation with the one another, and here also you are having is the 6 pi electrons, which means the Huckel's rule is getting being satisfied. That means this particular system, which is my pyrrole, is aromatic in the nature, right? Now next is for the furan, if you see. So here you have two lone pairs present on the oxygen atom. Like this, the double bonds are present. These double bonds are formed by the overlap of the p orbitals. I hope this thing is clear to you. So oxygen is having the lone pair of the electrons. So that is going to be present in the different p orbitals, because p orbitals are perpendicular to the one another. If px is in this direction, then the py orbital will be in this direction and pz will be perpendicular to this. That means all the three p orbitals are perpendicular to the one another. So if one of the electrons is present in the px orbital, the other one will be present in the py, right? That means we want that that only lone pair is gonna be in the conjugation which is going in plane rotation, that is in plane conjugation that is giving, right? So here is your px orbital. Now this another lone pair is gonna remain in the py orbital, so that is not gonna go in the conjugation, only the px orbital will be going in the conjugation. So here electron density is present, so this can transfer like this in the upper side. So here you can see the conjugation is present, and here we have 6 pi electrons are in the conjugation, because one of the lone pair that is present in the py orbital, which is perpendicular to the px orbital, that is not going in the conjugation. So here total we have 1 2 3 4 and the 5 6 pi electrons in this case also, which means my Huckel's rule is again getting being satisfied, right? Now next is for the pyridine, if we see. So if for the pyridine, so same for the thiophene also you can see, because sulfur is also belonging to the same group like that of the oxygen. So here also one of the lone pair will be going in the conjugation and the other is gonna remain in the perpendicular p orbital, that is not involved in the conjugation. Right now in the pyridine, let us see. So here we have this p orbitals will be present like this. So here on the nitrogen, one lone pair of electron density is present, and here the rest p orbitals are present, that is forming the bond over this sides. Right? So suppose this is your px orbital, which is having the electron density over them, and this nitrogen's lone pair that is present it will be present in the perpendicular orbital, which is my py orbital, and it is not involved in conjugation. It is not involved in conjugation. So overall we are seeing that this nitrogen's lone pair is not involved in conjugation. So overall these three pi electrons we are having, pi bonds we are having. So overall 6 pi electrons are present which are involved in the conjugation, because this nitrogen lone pair is localized over the nitrogen center only. It is not involved in the conjugation present in the pure py orbital. That is perpendicular, it cannot go into the conjugation, right? Now, so we can say that all these heterocyclic compounds, they are my aromatic systems. Okay, so we will be seeing these saturated hydrocarbons and the aromatic heterocyclic compounds one by one. So mostly as we will be focusing is on the aromatic compounds only, but a bit of idea about the saturated hydrocarbons, their reactions, we can have a look over that. Okay, so saturated heterocyclic compound, first one is your aziridine, which is my three-membered ring with the nitrogen present in it. Right now, first reaction we have for it is its acylation. Acylation means the treatment with the acyl groups such as your CH3, C double bond O, and the Cl. So this is the acylation of it, and the reaction we are gonna do it with the aziridine, which is my three-membered ring with this hydrogen center and this lone pair of electron densities present. Now this reaction can occur in two of the conditions. One will be in the presence of the base and other will be without the base. So we will be having without base. That means no basic condition has been provided, just the reaction of this acyl system with the aziridine and in the presence of the base. So both of these reactions in the different reaction conditions will give us the different products. So one by one we are gonna have a look over to that. Okay, so just a second. So this is Aziridine system we are having. Now the reaction in this we are gonna see. So here we have the acyl system, C double bond O and the Cl with this aziridine ring that is present. So now here the nitrogen containing the lone pair of electron density that can attack over this carbonyl center, which is electrophilic in nature. This electron density will be shifted upside. So we are gonna get here is CH3C with the O negative, and here will be your Cl group present over it. Now the nitrogen with this system and nitrogen with the hydrogen is there, since it has donated the electron pair, so a positive charge will be present over it. This electron density from the carbonyl system is gonna come back, and this Cl from the system will be leaving, right? So we are gonna get here is CH3 C double bond O and the nitrogen with this three-membered ring, and here is the hydrogen present, so a positive charge is there. Now here if I take in the absence of the base, now here is without the base, if I talk about without base, so in that case what is going to happen, this species that we have got C double bond O, here the nitrogen and this system is present. Now you can see that three-membered ring is there in the system, and that is gonna be strained ring. Along with that we are having the nitrogen with the positive charge, so electronegative atom with the positive charge, that is not stable at all. So what is going to happen, the Cl negative that has left from the system is gonna come for the attack like this, and this electron density is shifted to the nitrogen so that the positive charge over it can be neutralized, right? So we are gonna get here is CH3 C double bond O with the nitrogen containing the hydrogen, CH2 CH2 and the Cl group will be present like this. So this will be the, that means ring opening we are gonna get in the absence of the base, right? Now if I talk in the presence of the base, so with base, initial step will be the attack of the aziridine ring over the acyl chloride, leading you to the this product only, right? So with the base, what is going to happen next is we have this species CH3 C double bond O nitrogen with the hydrogen, and here is gonna be the positive charge present like this. Now if the basic condition, suppose we have K2CO3 is, which is a weak base, is passed, so this base is gonna come and abstract the proton from here, giving us the product which will be CH3 C double bond O, and here nitrogen will be present and three membered ring will be present. So we are seeing the different products obtained when in the absence of the base and with the presence of the base. So this is with base, here the ring is retained, ring is retained, and here is, if there is no base, then no ring is retained or ring opening is observed, ring opening is there. So this will be the conditions. So now based upon this concept, let us have a look over one of the question. So here you have this particular species on which there is attack of the aziridine, and the basic condition is given, leading to the formation of the product A, and then the attack of the A over this particular reagent, giving us the product that will be B. So let us have a look over to the question now. So first step will be this nitrogen containing the lone pairs is gonna attack at this particular site, because Cl it can leave from the reaction medium, because it is of the element of your third period that can easily leave because of the presence of the vacant d orbital in it. It is your good leaving group, right? So we are gonna get here is, in the first step is, rest species will be remaining the same. Now this CH2, it has formed the bond with the nitrogen, this aziridine ring that was having this positive charge, because nitrogen has donated its electron pairs, and here is OMe, and the OBN species is remaining the same, right? Now further is, they have treated this with the base, so base is gonna come and abstract the proton from here. So we are gonna get here is this species CH2, and the nitrogen group will be there like this. So in the basic medium, we have seen that my ring is getting being retained. Here my OBN will be there. So in the basic medium, as I told, the ring is getting being retained, right? So this thing is present. So this is your product A that has been formed. Now this A, they have treated with this particular species. So now again, ring is present, nitrogen is still containing the lone pair of electrons that will go and attack over this species, and this Br negative is gonna leave from the reaction condition. So we are going to get here is, now here this ring that was present, and here CH2 and the nitrogen it was present. So now here this ring will be present. This is gonna form the positive charge, and this is getting being forming the bond with the CH2, and here we have this species getting being formed, right? At the para position you have is your OR group. Rest substituent over here, that is OMe and OBN, are remaining the same, right? Now next is, in the absence of the base, there is gonna be the ring opening, because you are seeing we are having is a three membered ring, and with the positive charge present over the electronegative nitrogen atom. So in the absence of the base, we have is the ring opening. So for that, the Br negative that has left from the reaction conditions is gonna come and attack at this site, and this ring will be opened from the here, right? Leading us to the final product, which will be this ring is remaining the same. Here the substituents OBN and OBN are OMe are remaining the intact, and here CH2 with the nitrogen, and this has formed the bond with this six membered ring, that is your benzene, with the OR group, right? And this position, now here you have CH2 and the Br species is present. So this is gonna be your product B, and it is gonna be your final product. So here what has happened is, the main thing is, in the presence of the base the ring is remaining the intact, but in the absence of the base, that was when this A species is reacting with this particular reagent. In that case, no basic condition was given, so the ring opening is there. So this was about your Aziridine. So this much you can have a look over this, that the different conditions for the acylation can be there. Okay. Now moving on to our next species, which is our Oxetane species. So Oxetane basically means four-membered ring with the oxygen present in it. Right now here the reaction will be occurring is, suppose we have this Lewis acid, and in this they have passed is your butyl lithium. Okay, so what is going to happen with the BF3, which is your Lewis acid, this oxygen that is containing the lone pair of electrons is gonna attack over this acid, so leading to the formation of the oxygen with the BF3. Right, so oxygen, a positive charge will be coming. So now the electrophilicity at this particular carbon center is increased because of the presence of the positive charge over the oxygen, because oxygen is electronegative atom having the positive charge, so it is not stable at all. So electrophilicity, it wants that, oxygen wants that this positive charge to be neutralized as soon as possible. So for that, what is going to happen is, the electrophilicity on the adjacent carbon is now increased. So we have the butyl lithium 1, 2, 3, 4, and this lithium. So butyl with the negative charge, it is gonna be present. So that is gonna come attack at this center, and this charge over it can be neutralized. So we are gonna get here is O with the BF3. Right, next here is CH2, and this has this carbon, it has formed the bond with the butyl species that is present. Right, so next step will be the workup of this. So we are gonna get here is OH getting being formed, and here will be your this species getting being formed. So this is gonna be the product. So this was the case when you were given the Lewis acid. So this was in the presence of Lewis acid, how the reaction of the oxetane ring is gonna occur. So this was the final product for the reaction of your oxetane, which in the four-membered ring, Lewis acid is required, strain present in the ring, and after the workup you are gonna get is your this final product. Now moving on to our next heterocyclic, that is saturated heterocyclic compound, which is your tetrahydrofuran. So this is basically your five-membered ring containing the oxygen atom in it. Right, so now next is, what is going to happen here is the reaction we are gonna see. Here we have the Lewis acid, and which is attached with the OET, and here next we have is butyl lithium in this. So this is the reaction which is occurring in the presence of the Lewis acid, in the presence of Lewis acid. So here BF3 is your Lewis acid. So in this case, what is going to happen? The lone pairs present on this oxygen atom is gonna show the interaction with this Lewis acid. So here we are gonna get here is this species getting being formed. Right, so now oxygen has donated, so a positive charge will be coming. So the electrophilicity at this particular carbon has now been increased. So my butyl lithium, which is 1, 2, 3, 4, and the lithium is gonna come, this negative charge is present, will attack over this center, and this ring opening is gonna be there. So we are gonna get here is O with the BF3, and here is this ring, and here the attack of the butyl it has occurred. Now after the workup of this, so we are now doing is its workup. So for that, what is going to happen, here the species will be your OH, and here is your butyl attached over it. So here we have 1, 2, 1 carbon I have missed. So here we will be having is the OH, and here is 1, 2, 3, and here will be your butyl species. So this is going to be your product in which, where in the case where you have in the presence of the Lewis acid. Now the other case that we have is in the absence of the Lewis acid. In the absence of Lewis acid. What I mean in that case is, just you have is your Tetrahydrofuran species, and along with that just the butyl lithium is passed. No BF3 is passed. So in that case, what is going to happen? The lone pairs present on this oxygen atom will be showing the chelation with the lithium atom. So here we have is, this was Lewis acid. So here oxygen will be present. This is gonna show the chelation with the lithium, right? And here the attached species, which is my butyl with the negative charge. This at the ortho position will be abstracting the proton from here, giving us this species getting being formed. So a negative charge will be at this position now, having the lithium positive. Now, in the reaction condition, we do not have any other acid or the other species present in it. So, what is going to happen? This electron density will be shifted. So now here we have is this 5-membered ring having the negative charge at this position. So what is going to happen is, this electron density is shifted to this particular center. This electron density will be shifted and this bond is gonna break. So here we are seeing that this bond, so transition state, what we are getting is the oxygen is gonna have the negative charge because this electron density is getting being shifted. Now here this bond is present and here will be the formation of your double bond, right? And this alkene, this bond is getting being broken, and here is this bond present, and here will be the formation of this bond, and this bond is breaking with the oxygen, giving us the formation of here the O negative with this alkene getting being formed at this position, and the double bond will be present. So here finally we are getting is, so this might not be visible. So finally the products we are getting here is the O negative with the double bond and the alkene species getting being formed. That is, my enol is formed, and along with that my alkene group is getting being formed. So with the presence, in the absence of the base, we are gonna get is the enol and the alkene, and in the presence of the Lewis acid, we are gonna get is this type of the product. So this is the thing that you have to remember, or you can have a look over this. So now based upon this concept, let us have a look over one of the equation. So you have your tetrahydrofuran and it is treated with the butyl lithium. So no Lewis acid is given on the reaction condition, leading to the product formation A, which is treated with this particular substrate and giving us the product B. So what is going to happen here? Here we have is your tetrahydrofuran. Now here we had my butyl lithium. So oxygen having the lone pair is gonna show the interaction with the lithium. So here we will be having is lithium, and here butyl negative charge is present over here. So this is gonna abstract the proton from here, that is gonna give me this species. So here the negative charge will be formed and the lithium positive interactions will be seen. So finally, after that, what is going to happen? This electron density will be shifted. This bond's electron density is shifted and this bond's electron density is shifted to this oxygen atom, leading to the formation of the alkene with the enol species, right? So this is gonna be your product A. Now this product A, which is my enol species, this O negative, is treated with the species which is my SPH C double bond O and the Cl. So now we have here for the enol two of the positions for the attack. One is through this oxygen center and other is that after the stoichiomerization of it suppose it as occurring, this electron density is shifted and the electron density is at this position. So we have here is the carbonyl, and this is carbon is having the negative charge. So either the attack through this oxygen center can occur, or through this carbon center it can occur. So here we are seeing that carbon center is my soft center, and the attack is, if it is through this oxygen center, this oxygen attack is my hard. So based upon that concept, we have is the hard soft basic, hard soft soft basic interactions are favorable. So this O negative, and now we will be seeing in the substrate that if it is hard or the soft, based upon that the attack will be occurring. So here carbonyl species that is present, oxygen is having the negative charge and the carbon is bears a positive charge. So this carbonyl center basically is your hard center. So on this, the attack will be from the hard side only. That means here the attack will be from your oxygen center, because that is your hard center. So the final product we are gonna get here is this oxygen that has formed the bond with the carbonyl. Here the O negative and the S pH group is present. Here the Cl group was present. This group is gonna leave and this Cl will be leaving from the reaction condition, giving us the product which will be my here oxygen that is present, and here the C double bond O and your SPH group will be present. So this is going to be your final product, which is your product number B. So the concept here was that O alkylation or the C alkylation is based upon the site where the attack we have to make. So if the site would have been the soft, then the carbon center would have attacked. Now if it is the hard center, then the attack takes place from the O alkylation. So you can write down the examples for the hard centers attack that are generally occurs. So here we had was the Cl species that was present. So next possibility you can have is of the AC2O, which is my CH3 C double bond O, O C double bond O, and the CH3. Here also the hard site it is there, so the attack is gonna be your through the hard center only. Next is you can have is P double bond O, here the Cl and the OET. So all these are your hard centers, right? So that means the through the, if the enol is attacking, so through the oxygen center that attack will be there. So all these are my hard sites for the attack. Okay. So now moving on to our next question. Suppose you have is your this species now. So now here this particular substrate is in the first step is treated with the butyl lithium. Then with this species having the Lewis acid that is BF3, and then with the HgCl2 and the methanol is fast. So one by one let us have a look. So here we had was this substrate, here the hydrogen, here the sulfur atoms are present like this. One of the carbon I missed. So here this species is there. Okay, in the first step they have given us butyl lithium. Now the role of butyl lithium, it can be your, it can act as your base also. So it can act as a base. So going to look for the acidic proton. So here you can see butyl lithium. This will be acting upon this particular hydrogen center, which is my acidic proton, because after the loss here the negative charge will be formed, that is stabilized because of the two sulfur atoms present in the adjacent. They are having the vacant 3d orbitals they are having. So this electron density that is of the negative charge can be delocalized in the or d orbitals of these two sulfurs. So that proton basically is your acidic in nature. So here we have is the negative charge, and here your this species will be forming, right? So this is the first step. Now in the second step is the this ring we are having. So oxetane type of the ring is there, but here now n number of the carbon atoms are present in the ring, and here will be the BF3. So now in the with the help of the BF3, this oxetane type of the ring, here BF3 Lewis acid is present, so this oxygen will be protonated. Now this negatively charged species is gonna go, will be attacking over this particular ring, and this ring will be opened from here, giving us this species. So now here this sulfur and the sulfur is present, and here is this CH2 carbon with the next CH having the n number of the carbon atoms, CH2 and the OH species. This after the workup I am writing this thing. So this thing is getting being formed. Now next is they have treated this with the HgCl2 with the methanol. So this particular species is used for the deprotection. So this group that is present, this species will be converted to your carbonyl. So resultant you are gonna get here is this group getting being converted to the carbonyl, and here will be your CH2 CH having the n number of the carbon atoms, CH2 and the OH species will be present. So this is gonna be your final product. Okay, so main thing is you can remember that in which case ring opening is gonna occur or not occur, that is the main thing. So this was about your saturated heterocyclic compounds. So only this much we can, this much is important from the examination point of view, not much details of it is present, is generally asked. So we main thing is about this aromatic heterocyclic compounds that we will be looking upon from the next class. So all of these heterocyclic compounds, be it your furan, pyrrole, thiophene, pyridine, all of this we are gonna discuss one by one in the next lecture. Okay, so I hope this much is clear to you for the saturated heterocyclic compounds. But if you still have any doubt at any of the points that I have discussed so far, that you can ask me in the comment section. I'll surely reply to that. So we'll be meeting you in the next video with your aromatic heterocyclic compounds now. So till then, bye bye.